We've got x squareds, we've got x's, y's, constants. So you're going to follow the same steps every time. You're going to group together. If you had an x term, you put the x next to the x and the y next to the y. See how down here in number 2, you're going to have to move like the 4x next to the x squared. In this equation, x squared is the only x term, and the y's are already next to each other. So all we have to do to start the problem is move the 8 to the other side of the equation. And when you rewrite your equation, you want to leave yourself a little bit of room next to the y, because we're going to use completing the square to fill this equation in that spot. So you're going to move your constant to the other side. So I added 8 to both sides. So your next step is to make perfect squares out of everything on the left-hand side. I don't know if you learned about completing the square in Algebra 2 or not, but there's a formula. To complete the square, you cut the middle term in half and square it. So if I cut -2 in half, I would have -1, and then when I square it, I would have +1. If I add +1 in this spot, something special is going to happen. I have to also add 1 to the other side to keep my equation balanced. So this is a trinomial that is factorable now. And it's factorable into y minus 1 times y minus 1, right? Because the factors of 1 that add up to -2 are -1 and -1. Are you with me? So 1 was the special number that made this into a perfect square trinomial. And because it's a perfect square, I can rewrite my equation as y minus 1 squared. So x squared was a perfect square the whole time, but all of these y terms, to make it into a perfect square, I had to add 1 to both sides of the equation and factor it. So now I have an equation that's in standard form. I'm not going to rewrite it, but that's my standard form equation, and I can locate my center and my radius and graph it now. So my center, my x value, has not gone left or right. So my center is still at 0, but my y value has been shifted up 1. So we learned yesterday that when things are in parentheses, right, the transformation rule is the opposite. So y is going to go up 1. So my center is at 0, 1. And what is my radius? This is r squared in the equation. So r by itself is just the square root of that. So I want to draw a circle that has a center at 0, 1, and a radius of 3. So you just mark your center, and then I just like to dot my kind of 4 dots that are 1, 2, 3 units away, so I can just kind of connect them the best I can to sketch my circle. So just kind of, roughly sketch your circle using those dots. And that's a skill that you're going to use for ellipses and hyperbolas. You're always going to have to get your equation into this format using completing the square. If you want to write down the formula for completing the square, because you might not be familiar with it, you take half of the b term and you square it. So you take half of the middle term, the b term, and square it, and that is what you're going to use to complete your square every time. So let's do another one together. So on number 2, we have to rearrange our equation so that the x terms are next to each other. So x squared plus 4x, leave yourself a little bit of room to complete the square. You have y squared minus 8y, leave yourself some room to complete the square, and then equals -19 in this case, because you want to move the constant term to the other side of the equation. So we need to complete the square twice. I'm going to add something here, and I'm going to add something here. So I take half of the 4, which is 2, and I square it. So 2 squared is 4. So I'm going to add 4 to complete that trinomial. So that means I have to add 4 to the other side of the equation to keep it balanced. Then I'm going to do the same thing for my y trinomial, cut the -8 in half, gives you -4, and then -4 squared is 16. So I'm going to add 16 also to both sides of the equation. So you have to complete the squares, keep the other side balanced, then you're going to factor. And for this one, I'm going to factor it into the binomials, but if you are kind of understanding how to factor, you don't have to do this step. But I'm thinking about what are the factors of 4 that add up to 4. It would be x plus 2x plus 2, which is x plus 2 squared. So if you can see how to factor it, you can skip this binomial step if you want to. And then there should have been a plus sign right in front of that y squared. So plus, what does this one factor into? So what are the factors of 16 that add up to -8? That would be y minus 4 times y minus 4. So y minus 4 squared. So this is the toughest part, figuring out how to complete your square and then factoring it as a perfect square trinomial. And then I would just have 1 on the other side, right? -19 plus 20. You might end up with a number over here that's not a perfect square. So if you ended up with a 7 on this side of the equation or a 6, you just take the square root of it. Your radius might not be an integer, right? So if you take the square root of 6, your circle would just have a radius of whatever, 2 point something. So it's okay to have a radius that's not an integer. We got an integer because the square root of 1 is still 1. So my radius is at 1. This time I had x plus 2. So if it's x plus 2, it's actually to the left. So my center is at -2, but still at +4. So -2, +4, 1, 2, 3, 4, and it has a radius of the square root of 1, which is 1. So a really small circle that's been moved left 2 and up 4. So let's do one more together, and then I'm going to have you take 5 or 10 minutes and try the 3 on the back page yourself to really cement this skill before we apply it to some ellipses. Because I think that graphing a circle is pretty easy, right? Once you have the center and the radius, there's not much to it. The biggest skill that we want to develop is this equation, forming the correct equation. So your first step is to get your x's next to each other, your y's next to each other, and move your constant to the other side of the equation. So x squared plus 4x, leave some room. Y squared minus 4y, leave some room. And then I'll get +9 on the other side of the equation. So to complete these squares, you cut the middle term in half and then square it. So 2 squared is 4. You're always going to get a positive answer because you're squaring either a positive or negative number. You get a positive number, right? So you complete the square with positive numbers. So I'm going to add 4 to the other side of the equation to also keep it balanced. All right, I'm going to also add 4 in this slot, right? Because -2 squared is also +4. So I'm going to add another +4 on the right side, which gives me 17, right? That might bother you a little bit because 17 is not a perfect square, but you didn't do anything wrong. You just have a radius that's going to be the square root of 17, 4.1 or something like that. Square root of 16 would have been 4, right? So about 4.1. All right, so the shortcut to factor this, basically whatever half of this value was, that's going to be your like x plus 2, right? Because 2 squared gave me 4. So this is going to factor into x plus 2 squared. And this one's going to factor into y minus 2 squared. Did you notice that? Basically half of your b value before you square it is what goes into that slot. Right, because 2 squared gave me 4, -2 squared gave me 4. All right, so can someone verify for me, is the square root of 17 4.1? Okay, so my radius is 4.1, and my center is at -2, so left 2, up 2. So -2, comma 2. And 1, 2, 3, 4.1, just go just beyond 1, 2, 3, 4.1. 1, 2, 3, 4.1, 1, 2, 3, 4.1. So just a hair bigger than if it had a radius of 4. So don't let the non-perfect squares bother you, because there's more of them than there are perfect squares, right? When you think about it, you're more likely to have a circle that does not have an integer radius than to come up with an integer. Do you think you have enough information to try the back 3 problems? Because it's a skill that if you get stuck on this